Hello, ladies and gentlemen. Welcome to the next episode of Information Shelf, DSPy interview series. We often hear engineers trying to learn the domain that they work in. And in healthcare, it's usually medicine and lab reports, radiology, hospital information systems. And we see doctors sort of advising product teams. Today's guest is someone who can wear both the hats. Dr. Marius is board certified radiologist who actually writes code himself. He also created an online QA rack system for answering radiology questions, which, by the way, he coded himself. Marius, welcome to the show. How are you doing?
Thanks for having me. Yeah, I'm good. Thanks.
Okay, so, you know, I'm pretty sure all the audience would be curious. What's your formal education? How did you get into coding? So, if you can throw light on that.
Yeah. So actually, I had a very typical career for a doctor in Germany. So after school, I went to med school here in Germany, very typical. And then I started working in radiology as a resident at the University Hospital in Bonn, which is like the former capital of Germany, where I also studied. And I stayed there for about 3 years, and then 4 or 5 years ago, we moved to Düsseldorf, which is the city where I'm currently working and living in, which is like 60 kilometers north or so. And yeah, I'm a board certified radiologist, currently finishing up my neuroradiology fellowship. And I'm also like 50% working as a medical AI researcher at the university hospital. Yeah, I'm completely self-taught, so I never studied computer science or anything.
Oh.
Like, I think back in 2014 or so, I was a bit bored around Christmas, and I was always very much into computers and stuff. But I think I just opened up, I don't know how the website was called back in the day, Code School or something, and I just taught myself HTML, CSS, and JavaScript, and started with web development stuff. And then I wanted to build some mobile apps, so I tried to get into Android development, but Java was a complete pain as a beginner. I mean, all of the verbosity and like the type system was just too much. But yeah, so I was just self-taught because I wanted to build something. And actually, yeah, what brought me to like the whole machine learning AI stuff was I don't know how I heard about it, but I heard about the Fast AI course by Jeremy Howard back
Mm-hmm.
in 2017 or so. So one of the first iterations, and it was completely free. So I took it in like the semester break or whatever.
Okay.
And yeah, that was more or less like the gateway drug for me in the whole AI and ML space. And then I just kept going. I
And
started.
this is while you were still attending college for your medical.
Yeah, right. So I
I've got.
think I finished.
No, go ahead. Please go ahead.
Yeah, I think I finished up med school in 2018, and yeah, I started with Fast in 2017, and I still remember using like R, the programming language for like the statistics stuff for my scientific work in med school. Yeah, that was basically, how I got started. Yeah.
No, that's pretty impressive. I've got relatives on my mother's side who are doctors, and I cannot fathom how you took out time to learn programming while still at college. So that's pretty impressive. So with that, let's jump into the QA, question and answer radiology tool that you have. And if you can help me with the pronunciation of that name, I think it's
Yeah.
Wilhelm AI, right?
Yeah. Yeah, right. So it's Wilhelm AI. Wilhelm Konrad Röntgen is like the guy who invented like the X-ray
Ah,
stuff, and he's like the godfather of radiology. So
all
I
right.
thought it would be I I thought it was a funny name, to call it Wilhelm AI. Yeah, and I mean, the medical knowledge right now, it's exploding. I mean, I don't know how many like medical papers are released every day, but it's getting so much that nobody can actually keep it in their heads anymore. So we look up stuff all the time. We have always like a tab with Google or whatever open when we're reporting. And yeah, one of my big interests is how can we make this medical knowledge accessible through AI?
Got it.
Because nobody can sift through all the information anymore, and maybe we can use like information retrieval and AI to facilitate this. And in radiology, there is this website called radiopedia.org, which is a free Wikipedia-like website with radiology content. It's peer-reviewed and also written by peers. Yeah, it's like one of the main sources I use to actually look stuff up. And my idea was to use basically Radiopedia as a more or less live database for medical or radiology question answering. It works like it's a research project or like a research preview, so I think it's okay. But I'm more or less scraping the website. I'm generating search terms from the user query, and then I use the internal like Radiopedia web search stuff to find relevant articles, and then I use these articles as context to answer the question. So it's like a two-step process. So first I generate or extract like search terms from the user query, and then I search for articles, and then an LLM also like picks the most relevant articles from the list of search results, and then it's typical RAG basically. It's all written in DSPy.
Right.
Yeah, and it works actually surprisingly well. Yeah.
So I had a look at the code, right? And I think you're using Kimi K2 instruct model, right? And so a couple of questions, like how's your experience using DSPy? Because one of the things that you keep hearing that, the DSPy sort of has a sort of a steep learning curve compared to other, LLM interfacing libraries. So how was your experience? And I think it matters what your answer is, because you're someone who are self-taught and did not necessarily come to the data science sort of background.
Yeah. So I think it matters a little bit where you're coming from. So I'm coming from like computer vision and classical convolutional neural network. So I started writing PyTorch myself. And
got it.
To be honest, DSPy and PyTorch are very similar in you have modules,
forward,
and you have like optimizers and forward passes and stuff. So that wasn't very hard, to be honest. And that's like one of the main things I really like about DSPy, like these abstractions around thinking and building with LLMs. So once I got that it's more or less like PyTorch, but for large language models in the prompt space, it was actually kind of easy to wrap my head around. And also like I couldn't really fathom how to build these multi-step workflows that like build on each other in something else than DSPy, because like structured inputs and outputs are awesome for this, right?
It's very easy to build a pipeline.
Right, and you have like type safety between them, and it's awesome. So it was like a natural step for me to use DSPy for that after I realized what DSPy can actually do for me there. Yeah.
Awesome. I've got a question for you. So used Kimi to K2 instruct, right? Like there are a lot of medical domain specific models. Why not pick one of those as opposed to a general purpose one? And you could have gotten a better re-ranker, or just out of curiosity.
So actually, I mean, the LLM is not doing that much in the like medical space. It's more like the orchestrator for the whole pipeline. So it's the agent nowadays, basically. So it doesn't need really a lot of domain knowledge. And I mean, the problem with the medical specific LLMs we currently have is that they are all quite small. I think the biggest one is MedGamma B, which is now also like over a year old, and it's not as capable in like tool usage and agentic capabilities compared to something like Kimi. And but on the other hand, I mean, it's the whole, and that's also like a big thing of DSPy. It's more or less model agnostic. It's super easy to switch out the model and to test out new models. And so Kimi was just what was working best when I last evaluated a couple of models, right?
Got it. By the way, this week they launched the newer version, right? 3, right? For what do you call, for Gemma. So I think maybe you ought to probably run your benchmarks again. Maybe it's better.
Yeah, but it's also just the 4 billion models, so it's quite small, and I'm not really sure how good it is with tool calling and stuff. Yeah.
Okay. Does it happen with you, like your clinical brain is kind of fighting with your engineering brain and telling you don't ship this, these could have X, Y, and Z consequences. And I'm saying that because I've worked in healthcare, and it's one of those fields wherein the knowledge, the complexity, and the regulation and compliance all comes into picture, and the cost of doing a mistake which impacts a customer in the clinic or the hospital, or in terms of a report that you gave which has some wrong analysis to it, right? So like how do you rationalize both of these? How does this work?
Yeah, so actually it's maybe a little bit different than you might imagine, because I'm not really always concerned about the safety purposes, because to
Right.
be honest, there are so many like so low hanging fruit in like at least the German healthcare system. It's what I know best, that
Okay.
it's not really, I mean, we are not really talking about completely automating our reporting workflows on radiology. We're talking about very, very simple technical stuff. I mean, I think we're in Germany, at least in the healthcare system, are like the last people still using a fax machine. And that's not just a meme on Twitter. It's like,
Wow.
it's our day-to-day stuff. So that's what
I'm
we're
aware that
talking about.
healthcare. I'm aware that healthcare lags by 5-6 years any which ways, right? People are still using those desktop hospital management systems which don't have APIs,
Yeah,
and so I get that,
right, right.
and I saw this firsthand when working, and I think in some ways, it's for the right reasons. Okay, but I think I got the answer to your question into one of the papers that you're writing, which is still to be out, right? And in that
Yeah.
paper, you are saying, why not we do it this way? Why don't you tell us on a high level what the paper is about, and then I'll ask my follow-up questions.
Yeah. So one of the most important workflows, or like one of the things we do as radiologists, is if like one of the other clinicians in the hospital wants to have or wants to request an MRI, they fill out a form, like an order request form, where they basically state some facts about the patient, what the current problem is, and of course like the current question, the problem, why they want to have an MRI. And then what we do as radiologists is first we look through all the like the order entries, we call them, and we basically approve or disapprove them. We look whether they are or they have questions we can answer with an MRI, whether they are appropriate. And then what we have to do is we actually have to like specify the actual MRI we are doing. So in MRI, just very short, we have like different pulse sequences or different like possibilities to image different parts or like different tissue in the human body. Maybe there are like sequences which can visualize blood very well, or maybe something which can, I don't know, visualize water in the body very well. And then we have, we have to pick and mix and match like these pulse sequence to have the final protocol. And it's actually, you need to have like a deep domain knowledge, of course, in radiology, but sooner or later it's getting very repetitive. We do it for over hundreds of MRI requests every day, and it's very repetitive work. It's prone to be automated by AI, by LLMs, and that's what we are trying in this paper. It's not a completely new idea. Colleagues here also from Germany, from Cologne, which is like 20 kilometers away, did it like first back in 2023 when ChatGPT was very new.
Mhm.
But I mean, it's ChatGPT. We all know how it is to upload like
Yeah,
your own healthcare data to like
correct. Yeah,
ChatGPT. That's completely on your own. But I mean, that's your thing. But I mean, it's not very ethical to do this with actual patient data, because you just don't know what OpenAI is doing with the data. So one of the main problems I wanted to address or like explore in this paper was how can we do this in a data privacy preserving manner. And I know there are possibilities to do this in the big enterprise clouds like AWS,
right,
Bedrock, or Azure.
right.
But it's also like very hard to get this like data privacy compliant, at least in Germany, at least in Europe. So yeah, the logical thing is to use local large language models, and that's what we explored there.
Got it. And the model that you're using is MedGemma 25B, right?
Yeah, right. The 20B version of that, we self-hosted it on a small
Okay.
GPU cluster at our
Right.
hospital. And it's also like we evaluated a lot of open models. We also evaluated some Quen models and stuff.
Mm.
But the actual, like in this case, the domain knowledge was very helpful, to be honest. Yeah, and we also, we try to incorporate the information from our like standard operating procedures in our hospital into the system, so that
Okay.
it's like not generic for like, because every hospital has its very own way of like doing this MRI protocol definition.
Got it.
And so we had like a small rack approach, basically, more or less in that, so that we first try to basically classify the body region of the MRI. So if it's a head
Mhm.
examination or maybe a spine examination or whatever, and then we put the respective standard operating procedures for the MRI examinations in this body region into the context
Mhm.
with information when you should use whatever. And then we let it basically classify the order entry into whatever protocol we wanted to use.
Okay, so just catching up on that thought where you talked about that every hospital has its own set of regulations, procedures, and the way of doing things. So I understand it's completely hosted locally, the model and the framework on top of it communicating with it, and I'm assuming you're using DSPy. So are you fine tuning the model, or are you using some sort of prompt optimization? And as part of your context window, you have like you have these what we call procedures, etc., as part of the prompt. How does this work? If it's
Right.
prompt optimization, can you talk a little bit more about?
Yeah. Yeah. So we realized, I mean, the local models are getting better and better, but they're still way behind like the big frontier models, of course. So we have to like lower the gap, or like diminish like the difference between them. And we have like this inherent disadvantage if we
Mhm.
want to use local large language models to do stuff compared to like the big frontier models.
Right.
And yeah, we actually use the Zimba optimizer by DSPy,
Yeah.
like the predecessor of GEPA, to optimize the whole system, like both parts, like the body region classifier and afterwards like the actual classifier for the protocol. And yeah, it worked pretty well. I mean, it's a very defined task. It's very easy to evaluate because in the end it's a classification task with a lot of classes, but it's still like a classification task. So I sat down and labeled around 600 MRI order entries manually, and then we used this basically as a training and validation and test data set. And yeah, we saw like increases of like around, I think, 18% in accuracy. So from around, I don't know, 55% to around like 75% or so
Wow.
without changing anything in the model. And it was like 2 hours of training of prompt optimization on like 390s as like for inference. Much cheaper and much easier to actually get going compared to classical reinforcement learning, which is much more brittle in my experience. Yeah, and it worked very well, to be honest. And I think it's a very interesting
Okay.
approach to like having this privacy preserving local LLMs, but still getting like the most out of them, because I mean, they are still worse compared to like the big frontier models. Yeah.
How big was your example data set?
So as I said, I labeled 600 of them, but I did for at least classical machine learning a very untypical split of like 20% for training and 80% for testing. And then I also like, usually you would do it differently, but it's prompt optimization, and there you don't
Right.
really need that much data. And then I also like tried different training sizes. I actually found that doesn't really matter whether you have like a training data set of 30 or like 150 examples. It didn't really make that big of a difference in the results on the test data set. So it's also very interesting that it's very data efficient.
Okay, got it. Um, Another question, like if this were to the sort of setup you're building, if this were to get deployed in a hospital, right? It'll be used inside the room. The junior radiologist, the senior radiologist are investigating. That's the only place where it'll be used, or it's the doctor sitting in front in his own cabin would also be sort of referring to it. How does this sort of go into not production, sort of usage?
Yeah. So, I mean, we didn't really incorporate it yet in the production environment because like the biggest problem in healthcare is always getting the actual production data,
Right, right,
as you already said, you don't have a JSON API for like all of the systems we have, and
correct.
all of the systems talk in different protocols. So there are some protocols that try to unify all of this in a kind of JSON API. It's called Fire. It's a very neat idea, but nobody's using it anyway. So my wish would be to just have like a server running somewhere with a JSON API. It gets like the data
Right,
through an event or whatever through JSON, and then it's integrated in our system again through a JSON API.
got it.
Yeah, it's a dream of mine, but it's not really practical right now because healthcare IT is a complete mess. Yeah.
A quick question here. The PACS system, right? The radiology images, they are humongous in
Hmm.
size, right? Like a single image would be multiple of GBs, correct? So let's assume for a moment that you
Yeah.
had no bottleneck, okay, in terms of deploying this thing, right? And you have the full support of the board of
Hmm.
the hospital with you. So I reckon like you'll have to build a layer just to do a lot of feature extraction from the images, or are you going to sort of so you mentioned you'll just pick one part of the radiology image, right, like as part of the anatomy, and then sort of do the analysis for this, then the next, but I reckon even just that part, the image size would still be in hundreds of MBs, correct? So obviously you're never
Yeah.
going use say Maxime's attachment library and just push it to the model. So how does this work? Just curious, like what sort of feature extraction do you do to make this workable?
So usually, the file format we are working in the hospital or like with radiology content, it's called DICOM. It's like basically glorified JPEGs with a lot of metadata around it, and it's
Oh, okay.
uncompressed. So you're right, like an MRI scan is several hundreds of megabytes or a gigabyte or whatever. But that's not really what you're working with when you're like doing
Okay.
machine learning. You usually convert it into a format called Nifty. It's like it's great because then it's like more or less just the image array. And then you have like a single sequence of MRIs, like maybe 50 megabytes or so in data,
Oh, okay.
because you don't have all of the metadata around it. And then you can just put it in like a normal like
Understood.
convolutional
Got
neural
it.
network. Yeah. Either as like slices in 2D or like 3D, which is computationally a bit more expensive, but works as well.
All right. So kind of moving to the next question. So I worked 2 years at Aster DM Healthcare, which is one of the largest, if not the largest, healthcare provider in UAE. And the product manager that I worked with, the deputy head of product, he came from a medical background, right? As a formal education, then went to marketing, then became a product manager, and I could clearly see that someone who came from a formal study in a given domain, especially healthcare, right? They're just able to make better decisions. They are able to move faster. And we owe a lot of our success to him prioritizing the right things. Now, with AI coming in, and I don't know if you saw what the CEO of Shopify did, right? He took all his MRI scan report and he
Yeah. Yeah. Yeah.
not to build a whole software for him, right? To do the sort of the image reading for him. How do you see this evolve? See, doctors coming in, uh, not like you self-taught, but do you see education changing? Do you see doctors becoming more productive in terms of being able to build these softwares for themselves? Like, how do you see this sort of evolve?
Yeah, so I think it's a very important and also interesting topic because healthcare is, I think, much more nuanced and complicated from the inside than it seems from the outside. So, I mean, there's this famous quote by Jeffrey Hinton that we as radiologists are basically extinct now, but it's not the case because, I mean, I mean, radiology itself is much more complex from the inside than just,
Okay. Looking
I
at
don't
the
know,
yeah.
finding lung nodules on a CT scan. That's trivial for every experienced radiologist. And that's also why I think it's very important to have like people with actual domain knowledge and domain expertise inside of these product teams actually working on the products with them, because otherwise you will build something completely off the actual path that's helpful for doctors or for patients. Yeah, so I think it's a very interesting thing developing right now. I mean, with all of the modern AI tools like Cloud Code or Open Code or whatever, like
Right.
first of all, like the actual programming knowledge you need to build anything diminished, and also like the activation energy to try out something new is also like getting lower and lower. And I think this will ultimately like lead to more domain experts actually trying out stuff. But also like in like the bigger like product teams, I think having an actual healthcare professional on the team advising the team on how the healthcare system works is also very important, because I think, like, first of all, the culture is very different compared to tech. So we are usually moving a lot slower compared to the usual tech stuff. And also, like, usually the problems are not the actual tech stuff, what you can actually do from a technical engineering perspective, but usually the challenges around governance, around regulation, and yeah, data privacy, more or less, or like how can you actually get like the healthcare decision makers to try out something new. And I think also to understand like the dynamics in the whole field, it's very difficult for people who haven't worked in the space. And also like even like the problems you encounter are often much more nuanced and subtle, and that's also very hard to grasp if you're not really a healthcare professional in this domain. So yeah, I think it's like twofold. One, like the domain experts building their own stuff with tools like Cloud Code and stuff. And I see it with some colleagues who try out a lot of stuff using, I don't know, maybe also something like Lovable or these vibe coding stuff. And also like product teams needing the healthcare expertise from us doctors to actually build what's actually helpful. Yeah.
So you do see doctors building their own personal tools for their own personal practice or automating some workflows that they do manually. Okay.
Right. Yeah. So especially in radiology around reporting, it's not like automating the reporting, but stuff around like formatting it in a certain stuff. There's a whole discussion around structured reporting. Should like the MRI reports be in a structured like form, like structure?
Got it.
There are pros and cons to that, but now with LLMs, it's no problem to have like a normal free text, free flowing report and a structured version of that, or vice versa, because
Right.
you can translate it. And I see some doctors experimenting with this with their own tools, and also like, yeah, around all of this scientific stuff. I mean, the academia system is still also like very conservative and not much automated. So there's also like a lot of stuff around like having the right layouts for your scientific papers and stuff. That's something that Cloud Code can now do much better and much faster than we could. And it's just like menial work you don't want to have to do anymore. And I see a lot of people actually now also experimenting with this kind of stuff. Yeah, so it's very interesting. Yeah.
Awesome. I've got a question on evals for you. When it comes to evals, especially in radiology for image analysis, how does that work? What do your evals look like?
Yeah, so I mean, for medical image analysis, it's a little bit easier than for like generative AI things with LLMs, because in the end, like medical image analysis is a discriminative task, like classical machine learning, and
Mhm.
you just need a validation data set, and then you can work from there. And actually creating this validation data set and labeling all of the images, that's still like the bottleneck in medical AI. And it's nothing that you can really automate, because that's something where you have to be sure that
Right.
the quality of the annotations is stellar, because that's what basically determines how good your algorithm, your system is. And that takes usually a lot of domain expertise and a lot of time from a domain expert. But if you have a well-labeled data set, then it's actually quite straightforward. So we did some work on brain aneurysm detection in MRI scans. So brain aneurysms are these little bulgings of the vessels in the brain, and they can rupture, and that's a very bad thing. And we created a deep learning network which can detect these brain aneurysms on MRI scans. And we found that basically the quality of the annotations is what determines the quality of the system later. And that's also what we see with LLM systems. Usually what determines the quality of these systems is how well can you iterate on this, how well is your whole pipeline for error analysis, and how well can you like work with your traces and stuff. And it's more or less the same, but with image analysis, it's a bit easier because like the actual target is much easier to define compared to question answering, for example,
Got it. Got it. Awesome. This sort of brings me to our last question of this interview. What's your wish list on DSPy? Anything that you want to put out?
Yeah, so I thought about that, and actually it's something that we discussed in the DSPy community before I opened up a pull request back in September. So I think for like making or having a stateful module for DSPy, which keeps track of the conversation history on its own. And this is actually connected to what I would like to see in the DSPy ecosystem. It's some kind of abstraction above DSPy. So if we compare DSPy to PyTorch again, I think it's a very apt comparison. Then we need something on top of that to make like experiments a little bit faster, something like FastAI for PyTorch or Keras. Which also enables us to build agents faster, because I think DSPy is like the perfect environment for all of these modern agentic systems. We have so many great abstractions like recursive language models, which dropped 3 days ago, so I think as an experimental feature in the library. And it's also like prompt optimization. If you have like an agent which does a well-defined task, which you can evaluate very well, prompt optimization is much, much easier and much, much better also to interpret compared to like weight-based reinforcement learning. And I think that's something I would like to see, some abstraction on top of DSPy to make all of this agent stuff a little bit more ergonomic, basically.
Got it. Got it. Does it have some, like I was looking at your code and it had like a conversational manager implementation in the QA AI RAG system. So something like that, but with traces of chain of thought and like sequence-based conversational iteration of the assistant and the role.
Right.
User and the assistant. Okay. That's it.
Right. So that's something I came up with myself, but I think it's just very rudimentary, and there are a lot more things you can do if some people are working on that together, and some people which are a little bit more clever than me, actually coming up with abstractions which help in this regard. Yeah, that would be awesome.
Awesome. Marius, thank you for giving us your time. It's not every day we run into folks who are able to wear two hats like you are. Thanks for your time.
Yeah, thank you for having me. It was fun. Thanks.
Bye. Thank you.